This is Chapter 2, Section 2, Part B. We're going to be looking at unit conversions today, but more specifically, today we're going to focus on SI prefix conversions. So you definitely need your SI prefix table out. You need your calculator. Now, in the past, if you've had physical science or you've done other conversions with SI prefixes, they've asked you to find the difference in exponent, and you would move your decimal left or right so many places. But that is not how I'm going to teach this. I'm going to teach our conversions in a way so that it forces you to set up grids, what I call grids, like you were doing dimensional analysis, to prepare you for other math problems that we're going to have very soon where you can't just move decimals left and right to find an answer. So I will be teaching it differently. Some things you need to know, though, if you were trying to balance your scale, for instance, in this one, 532 meters, we have a number and we have a unit. If we're converting to kilometers, kilometers is a larger unit than meters. So to balance it, I need a smaller number. And we're going to figure out how do I get that smaller number today to set up a grid and solve problems like this. So again, you have your SI prefixes table. You're going to need it. We are focusing on where it says factors. We are looking at those exponents. Very, very important. We got to focus in on those exponents. Again, mega is a capital M. I see a lowercase m for milli. Don't forget, we've got a couple other lowercase m's out there. We have a lowercase m for mass, which is a quantity. We have a lowercase m for meter, which is a base unit. And now we have another lowercase m for a prefix, meaning milli. So I can put milli and meter together for millimeter, which is a length unit, and you would have two lowercase m's that would put together. But again, those exponents under factor, that is what we're going to focus on to figure out, hey, how do we set up these grids? So before I get into actual SI prefix conversions and how I'm going to want you to set them up, let's go to a set of English conversions that you should be pretty familiar with, how the numbers are set up, but you've probably never thought about it quite like this. So if I asked you to calculate how many seconds are in 1 week, I think if I gave all of you a little bit of time, you could easily figure this out. And you might all go about it just a little bit different way, but I feel confident that most of you could get the correct answer. But I'm going to show you, I like to use something called a grid. Basically just looks like a T. Anything that is above this red line is considered to be in the numerator. Anything below the red line is considered to be in the denominator. And this vertical line, I'll color it orange, represents multiplication. So anything above the red line, numbers in each of these boxes would be multiplied. Anything below the red line, each number in those boxes below the red line would be divided. So let's get to it. I asked you how many seconds are in 1 week. So my given information is 1 week. Well, my first set of numbers I would probably want to go to is days. And you know how many days are in 1 week? Well, in 1 week, there are 7 days. Great. Again, if I'm working numerator, denominator, I should be able to see that weeks cancel, not the numbers, but the unit week cancels, and now I can move on over to days. Well, from days, I can go from days to hours. Awesome. In 1 day, how many hours are there? There are 24 hours. Okay, I can cancel out days now in the numerator and denominator, but I'm still trying to get to seconds. So I set up another part of my grid. Got some extending to do here. So hours, still trying to get to seconds. Well, for most of us, from hours, we would go to minutes. And you know how many minutes are in 1 hour. It is 60 minutes in 1 hour. And now I can see that hours cancels, and we're left with minutes. And we would need to go one more step and go from minutes to seconds. And I know that you are all aware of how many seconds are in 1 minute, and that is 60 seconds in 1 minute. And now we are ready to solve because minutes cancels. Notice my only unit that did not cancel is seconds. And when you put all of this into the calculator, it is going to look like this. 1 times 7 times 24 times 60 times 60. Technically, we would divide by everything below the red line since it's in the denominator. But if you divide by a bunch of ones, it's not going to change your answer. But again, divide by 1, divide by 1, divide by 1, divide by 1. So it will essentially be 1 times 7 times 24 times 60 times 60. And again, divide by a bunch of ones is not going to change your answer. So when you do that, your answer is 604,800 seconds is our answer. As I look at this too, again, this is what I'm calling dimensional analysis. We are analyzing different dimensions or different units, and we are converting from one unit to another. What I'm setting you up for is we're going to go to SI conversions, which you don't normally deal with every day. So we're trying to just show you that one is correlated to another. Notice that whatever I have starting off with, which is my given, that unit is there, is repeated diagonally below. Whatever unit we compare to next, day, is repeated here. And then for the next unit, hour, repeated right down here. Next unit, we've got minutes repeated right down here, and then our last unit is the unit we want to keep in our answer. And we're going to have that same type of setup for our SI prefix conversions. So this is the set of SI prefix conversions we're going to look at, but I am going to go through a 5-step process that I want you to do. Again, it's going to sound like overkill if you are already very familiar with SI prefixes, but again, I am trying to get your mind in tuned with dimensional analysis when we go into conversions that are not just simply moving a decimal. So let's get started on what those are. Okay, SI conversion steps, and you're going to make sure you get all of this written down. Step number 1, you're going to set up a grid. And for all of, if it is a straight SI to SI conversion within the same quantity, it is always what I call one step. And that one step, that's what I call one step, because our given goes into this very first part, and we will have nothing right under here. Okay, nothing there at the bottom. So your given information goes in there. Step number 2, we're going to place our units. So you will have in step number 1 a certain unit that goes right here. Well, that unit gets repeated right down here, whatever that unit is, and the unit that you are going to will go here at the top. So the unit that you are trying to find goes at the top. Step number 3, we will place a 1 with the larger unit. So where I have the green and orange arrow, a 1 will go in front of one of those, whichever unit is larger. So this is where you have to look at your SI prefix table. The larger the exponent, the larger that value is. So that's how we figure out which is larger. Step number 4, we're going to find the difference. Difference means to subtract, so find the difference in exponents. So let's take our larger unit minus the smaller, I say larger unit. How about the larger exponent? Larger exponent minus the smaller exponent, and that will give us some value. That'll give us some value. Okay, step number 5. By the way, in step 4, even if you got the smaller and larger backwards and you came up with a negative number, I'm only concerned about the actual numerical value, not the plus or minus that is in front. So step number 5, we will put that number of zeros behind a 1 with the smaller unit. So whatever value that you get within this box, that is how many numbers we will, or how many zeros we'll put behind a 1. So it'll be 1, 10, 100, 1,000, 10,000, a million, whatever it is, but that's how many zeros go behind the 1. That way, up here in this box, we're never going to work with numbers less than 1. It'll always be a 1 and some value greater than 1, never decimals. Never decimals. So there are the 5 steps. You're going to need to see them in action. So let's go work out some examples. You keep these 5 steps handy. You have out your SI prefix table with all of the exponents, and you also have out your baby calculator. So I've included a picture of the SI prefix conversions, at least the one from the PowerPoint. You have a more extensive version on the copy that I gave you. So for the first example that we had listed earlier, we had 20 centimeters was given. It asked us to go to meters. So I'm going to set up my grid. And my given information was 20 centimeters. That is step number 1. Step number 2, we place our units. Well, I told you in step 2, whatever unit is here must be repeated there. So centimeters goes at the bottom. It is asking us to go to meters. So meters there at the top. Step number 3, we put a 1 with the larger unit. Well, as I look at this, my units that I am looking at are going to be centi, and then in front of meter, there is not another letter. That means I must be at the base for meter, which is 10 to the 0, and for centi, that's -2. Well, which number is larger, 0 or -2? It's the 0, so my 1 has to go on top with meter because it has the larger exponent. Okay, step number 3. We just did that. We put a 1 with a larger unit. Step 4, find the difference in exponents. So we said our exponents were 0 and -2. I said take the larger exponent minus the smaller one. So 0 minus -2 equals 2. Step number 5, we put 2 zeros behind a 1 with a smaller unit. So that is a 1 with 2 zeros, go with centimeter. Now I'm ready to solve. 20 times 1 divided by 100 gives me 0.2 meters. So we went from a smaller unit to a larger unit. That meant my number had to get smaller, and it did. So notice centimeters cancels. I'm left with meters, and I have done all the parts I'm supposed to. When we get into class, and we're going to have a few more examples before we go here, but when we get into class, I want to see all of this work. All of this work. Okay, next example. It was 0.032 liters, and you had to convert from liters to milliliters. So there is step 1. I set up my grid, and I put my given information in first. Step number 2, we place our units. Well, whatever unit we start with has to be the unit that we're going to. So that is liter, and it asks us to convert to milliliter. Step number 3, we put a 1 with the larger unit. Well, we have to figure out what exponents we are working with. So under liter, there is not a prefix, so no letter in front of it, so that must be the base, so 10 to the 0. And then the little m is milli. It is milli, which is 10 to the negative 3. Okay? So 10 to the negative 3 is milli. Step number 4. We have to, Step number 3, put a 1 with a larger unit. So our base is larger than milli. I'm going to put a 1 with liter. Step number 4, we find the difference in exponents. The base is larger, so 0 minus negative 3 is 3. Step number 5, we're going to put 3 zeros behind a 1. So a 1 with 3 zeros, that's 1,000. Next to my smaller unit, right there. And now we're ready to solve. Liters cancels. 0.32 times 1,000 divided by 1 is equal to 32 milliliters. 32 milliliters. We'll head on over to another example. And again, I'm getting these off of one of the slides I had shown you earlier. 45, that symbol is micro. It almost looks like a cursive italicized U. Micrometer. 45 micrometers, and it asked us to convert to nanometers. NM nanometer. Step 1 is on here. I've put my given in the grid. Step 2, place your units. Again, if micro was already used, I have to repeat it right here at the bottom. So that is micrometer, and we are going to nanometer. Step number 3, put a 1 with a larger unit. So if I go and I check out my units that I have here, I have micro and nano. Micro is to the negative 6, nano is negative 9. I would say that negative 6 is larger than negative 9. So micro is going to get the 1. Step number 4, find the difference in exponents. Well, we said negative 6 is larger than negative 9, so negative 6 minus negative 9 equals, those two negatives, negative and negative 9, become a positive, so it's really negative 6 plus 9, which is 3. So in step 5, I need a 1 with 3 zeros in front of nanometer. A 1 with 3 zeros in front of nanometer, and we are ready to do our math. Micrometer cancels. 45 times 1,000 divided by 1 is equal to 45,000 nanometers. And then let's work out one more example. I'm going to try to squeeze it in up here at the top. We had 805 dm, which is decimeter, and we're converting to kilometer. Decimeter to kilometer. So step 1, put my given there. Okay. So decimeter, step number 2, place our units. I'm going to repeat decimeter at the bottom, and we're going to kilometer. If you say kilometer, that's fine. You're in Tennessee, don't really care. 805 decimeters to kilometers. And then step number 3, we put a 1 with a larger unit. So again, we have kilo and deci. Kilo is to the third, deci is to the negative 1, so 3 is larger. I'm going to put my 1 with kilometer. And step number 4, find the difference in units. Well, we said 3 minus negative 1, so that's like saying 3 plus 1 is equal to 4. So we need to put a 1 with 4 zeros with decimeter. Now we are ready to solve. 805 times 1 divided by 1,000. And my final answer is, I'm going to erase some of this just to get it out of the way. Final answer is, oh, I needed 4 zeros. My bad. So that is really 10,000. So the comma should be right there. So it's 805 divided by 10,000. It's supposed to have 4 zeros. So our final answer, 0.0805 kilometers. 0.0805 kilometers. Again, we're going to do plenty more of these. Make sure that you understand this grid, the setup of it. You have those 5 steps ingrained in your notes. You are very comfortable with your SI prefixes, looking at the exponents. So again, and I do want to add just a couple other things. Again, so in the English unit, you know that, I'm just going to write it down. So you know that 60 seconds is equal to 1 minute. You know that there are 365 days in a year. Some other things you know that there are 12 inches in 1 foot. I'm sure that you can name off plenty others, but these are called equality statements. Something equals something else, even though you've changed the units on it. So I want to add a couple more equality statements that you may or may not be familiar with. One you were introduced to in the previous podcast. 1 centimeter cubed equals 1 milliliter. Okay, so they are a 1-to-1 ratio. And then also 1 inch is equal to 2.54 centimeters. So centimeters and centimeters cubed, that's going to be SI units. Milliliters, a non-SI system. Inches is an English system. So we can convert between different systems if you know the equality statements needed to do your conversions.